Nowadays, smart devices and autonomous vehicles have become increasingly common in our day-to-day life. But have you ever wondered what if someone attacks the device and injects a malicious program into it? Hi, I am Archit Jaiswal, and today I will be talking about remotely authenticating an IoT device. Before we dive deeper into the discussion, let me give you a brief background about what is an IoT device. It is a network of embedded devices that comprise electronics and software and are capable of exchanging data. For example, wearable technology like fitness tracker, smart home appliances like TV, refrigerator, etc. Built-in sensors of automobiles, all the way to autonomous vehicles and unmanned drones that are being used for delivery packages. This technology reached $100 billion in market revenue for the first time in 2017, and forecasts suggest that this figure will grow around 1.6 trillion by 2025. Majority of these devices are built using existing open source IoT platforms. For example, some widely used open source platforms are Zeta, Arduino, OpenRemote, Node-RED, etc. These open source platforms are developed by some people and it is available free of cost. Several hobbyists and industries involving the autonomous ground rover related activities usually use open source softwares like LibrePilot or ArduPilot's ArduRover. For the UAVs, there are options like Betaflight, PX4, etc. to build autonomous quadcopters and planes, other things. These open source platforms are usually unregulated and they are vulnerable to attacks. Users are usually unfamiliar with the architectural design of the open source platforms as they use it for a particular use case. Hence, the user is unaware of the potential vulnerabilities. Several IoT devices has been attacked in the past, which results in huge economic loss. For example, Trifo vacuum cleaner was attacked to cause denial of service. And millions of Windows 7 based IoT devices are susceptible to denial of service and loss of sensitive information as Microsoft discontinued to issue security patches. Now that we have seen the challenges of using an open source IoT framework, let's talk about how can we remotely authenticate the IoT device. So conventionally, security comes at a cost of exploiting processing power and memory. And as we all know that IoT devices are always constrained on resources. Therefore, we need to create an efficient framework that has a low overhead cost. Each IoT program consists of decision branch and execution loop. So what we can do is we can utilize to generate a unique watermark in every execution cycle using these decision branches. When a device is under attack, the malicious program tries to alter the original control flow. And as we can see on the right, an adversary had tried to attack an IoT device and injected a malicious program. Now this malicious program is trying to change the control flow of the IoT device. And we can see the original control flow is in the blue and the altered control flow is in the red. So if we have created a watermark using these branches of the original control flow, then the watermark will change due to the control flow hijacking. And we can easily detect this change in the watermark. Now I will talk about my journey of embedding a unique watermark in an IoT program. First of all, we all know that the software-based security approaches are harder to identify and clone by the attacker. I used a control flow graph to identify the sensitive variables present in the program. Sensitive variables are the ones that are present in as many control flow or execution blocks as possible, and they are non-static, which means that they can change in every control flow branch or execution cycle. Just to explain my procedure, I have created a short and sweet control flow diagram, and we can see that on the screen. Control flow graphs could look really complicated because the control flow graphs usually express each and every execution branch that a program has, and it tells you what the program will do if a certain condition is true or false. So on the screen, we can see this common variable named Archit. Yes, I created the sensitive variables just for the demonstration purposes. So what I am doing is I am using this sensitive variable which is named Archit, and I am every time changing it and assigning it a new value as I am creating my watermark. So if the execution cycle is going towards the branch that is true, then it will assign a unique value to this sensitive variable. And if the execution cycle goes towards the branch which is for false, then it will again assign it a different unique value. And that's how it will keep on changing in every execution cycle. Now, if this control flow graph is changed by the attacking software, then the value which is stored in the sensitive variable, in our case in the variable Archit, this watermark value will be drastically different than what we should be having. And that's how we can easily detect that the control flow of the program has been altered and the device is under an attack. My approach of remotely authenticating the IoT device is pretty straightforward. Here is the algorithm for it. So first of all, we are giving the input of a NEC program, and then we are generating the control flow graph. Then we are identifying the sensitive variables present in the control flow graph, and we are using these sensitive variables to create a unique watermark. So as we can see on the right, we have an input program that is going in the execution cycle, and then once it is executed in the very first cycle, we will be able to identify that is it the same program that we have created or not. If the signature verifies, then yes, we will again go back to the execution cycle, and now the program is in the execution and it will keep on executing on the IoT device. But the moment we find that the signature is different than what it should be, then right away we will stop the execution, and that's what proves that the program is under attack and the actual control flow of the IoT device has been altered. As the part of my research, I have done analysis on several of these programs, and on this table you can see that I came to a conclusion that all these programs have different number of control flow blocks and they have different number of sensitive variables, and there is no such relation in the number of control flow blocks and the number of sensitive variables. And there could be a case in where we do not have any sensitive variable in a program. In today's discussion, I talked about what is an IoT device and what are the challenges of using an open source framework for an IoT device. We saw that the software-based approaches are harder to detect for the attacker, and we can insert a watermark that has negligible computational cost penalty. I also talked about the sensitive variables present in the software, in the programs. If the sensitive variable is missing in a program, then we can easily embed it using just a 32-bit register, and we can create a sensitive variable in the entire program. Now, some of the future goals of my research is to implant a watermark on a pre-existing embedded software, and also to conduct the performance analysis after embedding the watermark in the pre-existing software. Thank you so much for listening, and thank you, University of Florida, for funding my project.